continuous integration, continuous deployment, and build tools. Learning objectives. By the end of this lesson, you will be able to describe the importance of continuous integration and continuous deployment, list the features of Jenkins and demonstrate their uses, list the features of Team City and demonstrate their uses, and select a suitable tool for your organization. The overview and importance of continuous integration and continuous deployment. Overview of continuous integration. Continuous integration is a development practice of combining code from a number of different developers into a common code base intended for deployment. Each integration event is verified by automated build and automated tests. There are many aspects to a continuous integration, also known as CI, process. Continuous integration is a development practice of combining code from a number of different developers into a common code base intended for deployment. Each integration event is verified by automated build and automated tests. There are many aspects to a continuous integration, also known as CI, process. These are develop and compile code, perform unit tests, integrate code with various types of databases, perform pre-production deployment activities, for example, moving code to various types of computing environments, such as testing and staging. Also, part of a continuous integration process is to perform functional testing and apply labels against release points in the code repository. Additional activities in CI are to generate reports and analyze the code. Continuous integration is about combining code from each developer into a common deployment path automatically with a high degree of accuracy. Continuous integration is more than a developer just creating some code and committing it to a feature branch he or she is working on for automation to pick up and deploy. Instead, the developer needs to make sure that he or she writes unit tests that exercise each line of code written. The purpose of unit testing is to prove that the code that's written works to expectation. A standard feature of most shops that practice continuous integration is to have the process run all the unit tests in a developer's work branch before merging the code into a common code base. If the unit tests don't pass in the automated process, the developer's code is not merged into the common branch. Then, the developer is typically notified, either by email or by another communication channel, that there's a problem that needs to be corrected. Overview of continuous deployment. Continuous deployment is an extension of continuous integration. Its purpose is to reduce the time between a development team writing code and then using it in production. The benefits of continuous deployment are not only that it provides faster feedback from end users as each new feature is released to production, but it also realizes a faster return on investment for each feature as it gets developed. For the most part, continuous deployment is a highly automated process that reduces the need for human interaction in the deployment process. Scripts take over most of the work that used to be done by humans previously involved in the physical deployment of code. Not only does automation copy code from one computing environment to another, the scripts will actually create the computing environments that need to be in place before you can move the code along. Automation reduces the time it takes to get code from developer to end user and increases the accuracy of the code that's being produced. Continuous deployment makes sure that the right code is in the right place at the right time. Popular tools in continuous integration and continuous deployment. The more common CI/CD tools used in IT shops practicing DevOps are Jenkins, Travis CI, Bamboo, Team City, and GitLab. Continuous integration with Jenkins. Jenkins is one of the more popular tools in the DevOps landscape. It's a powerful framework that supports a broad plugin ecosystem. Instead of having to write code on a line-by-line basis to extend the power of Jenkins, developers write custom plugins to add new functionality. These plugins are highly reusable. so much so that a whole marketplace has evolved around the product. There are now over 1,000 plugins available, and most of these are free. Also, Jenkins integrates with over 100 other DevOps tools such as GitHub and testing tools from a variety of vendors. Jenkins allows DevOps personnel to reliably orchestrate the release tool chain, and it's designed to be an end-to-end solution. In order to get full benefit from using Jenkins, aspiring DevOps personnel need to understand the standard phases in the CI/CD pipeline. These phases are code and commit, build and configure, scan and test, release, and deploy. You're going to incorporate a variety of tools with Jenkins during each phase of the process. During code and commit, developers use an integrated development environment, also known as an IDE, to create code. The popular ones are Visual Studio, Visual Studio Code, and Eclipse. And then they'll check the code into a version control system such as Git, GitHub, Perforce, or Mercurial. Some code might require binary dependencies that are stored in an artifact repository, such as Artifactory. After code is created and committed, it needs to be built. If the code requires compilation into a binary file such as a DLL, exe, or jar file, Jenkins will use a build system such as MS-Build, a C compiler, Maven for Java, or Ant for more general purposes. If the code needs to be containerized, you'll use Docker. Some IT shops will automatically create computing environments during build and configure in anticipation of impending code deployments. Tools such as Puppet, Chef, and Ansible can provision virtual machines automatically according to predefined configurations. During the scan and testing phase, you'll integrate Jenkins with testing tools such as JUnit, JMeter, Cucumber, or MS Test. Front-end testing can be conducted using Selenium, Appium, SauceLab, or Hewlett-Packard products. The purpose of scan and test is to make sure the code meets quality standards and is safe to move forward in the CI/CD process. The release phase is the last stage before code is released to users. You might integrate Jenkins with tools such as udeploy, Serena, Midvision, or XL Release. Finally, for deploy, you'll go on-premises to a cloud service or a hybrid combination of both a private on-premises cloud and a public cloud. For public cloud deployments, you'll target Amazon Web Services, Google Cloud, Azure, or IBM Cloud. Also, we're seeing cloud orchestration technologies such as Kubernetes take an increased presence as a release platform. For a private cloud, there's OpenStack. If you're working directly with virtual machines, you'll integrate Jenkins with VMware products or Docker. At a high level, in terms of application runtimes, you'll need something like the JBoss Java Virtual Machine or the WebSphere Application Server. Jenkins provides operational consistency in the various stages of release, regardless of the particular products you plan to use. Thus, you'll do well to keep these phases of deployment in mind as you continue on your journey to DevOps mastery. Continuous deployment with Jenkins. As you can see in the slide, continuous deployment, which we abbreviate as CD, consists of 5 operational stages. The first stage is coding, which is typically done on the developer's local workstation. The next stage is storage. During the storage phase, a developer commits his or her code to a source control management system such as Git, moving the code into a separate test computing environment, ensuring that the code is implemented in the best way possible, in addition to ensuring that the code works according to expectation so that it can be released to production is done in the quality assurance and testing stages. Production is the final stage in the release process. Production is where the code is made available to end users. The value that Jenkins brings to the software development lifecycle is that it can be configured to automate every stage of the entire process. This is very important because it not only speeds up the software development process overall, but also increases the accuracy and reliability of the code under development. Companies such as LinkedIn, Google, and Facebook have made continuous deployment a fundamental part of the way they make software. It's only by using an automation tool such as Jenkins that effective continuous deployment is possible. Doing deployment manually is time-consuming and costly. Those who adhere to the principles of DevOps understand that continuous deployment is an essential part of the practice of software development in the modern enterprise, and automation is key to the practice. Continuous integration with TeamCity. TeamCity is a free continuous integration tool from JetBrains. The company is best known for its integrated development environments for writing software. The abbreviation for integrated development environment is IDE. TeamCity is a complete continuous deployment, continuous integration system designed to automatically manage all aspects of the software development lifecycle. TeamCity is designed to integrate with all the popular products used in modern software development. It integrates well with the standard web browsers. As we've learned previously, communication among and between teams is important. Thus, TeamCity can be configured to send out notifications using email, RSS, chat tools, and social media platforms such as Slack. It supports version control by integrating with source control management systems such as Git, Subversion, Perforce, as well as many others. TeamCity supports all the build tools and development frameworks commonly found in the enterprise, such as Ant, Maven, MS Build, and Grunt. Also, TeamCity can be integrated with popular IDEs such as Eclipse, the various JetBrains tools such as IntelliJ, WebStorm, and PyCharm. TeamCity also integrates easily with the industry standard for developing Microsoft technologies, Visual Studio and Visual Studio Code. Continuous deployment with TeamCity. A good way to understand the workflow that TeamCity is designed to manage by way of automation is to conceptualize the software development process as having three areas of activity: artifact, deployment, and operations. Let's take a look at each area in detail. Artifact activity is about managing the various code components that make up a software system. Some shops use the term deployment unit to describe the distinct component of code that needs to be released into production. Other shops use the term deployment artifact. Some of these components might be a binary file such as Java or a jar file, or in .NET shops, the artifacts can be an exe or a DLL file. Linux doesn't have the concept of file extension-based executables. Thus, any file can be an executable. You just need to have the right permission set. The important thing to understand about the artifact area is that it's about creating and managing deployment units that will be released to production. Deployment. Once an artifact or a collection of artifacts are ready for release, they need to go through a company's deployment process. There are a number of tools and processes associated with deployment activity. The ultimate goal of the deployment activity is to make sure that working, valuable software gets to the customer as quickly as possible. Typically, companies will use a ticketing system to control and monitor the work that needs to be done in deployment. Artifacts will be prepared for deployment. Computing instances will be provisioned. Sometimes the provisioning might involve creating virtual computing instances, such as a virtual machine or container. Other times it might require installing physical hardware, such as computers and networking devices. Then, after provisioning is complete, the deployment artifacts are configured and pushed into relevant computing environments. And finally, we get to operations. It's important to understand that a comprehensive CI/CD system, such as TeamCity, goes beyond just deployment activity. TeamCity will also automate a lot of operations activity. Release personnel can use TeamCity features to orchestrate computing environments and monitor activity in those environments. Also, it coordinates important aspects of enterprise-level DevOps, such as logging and aggregating security alerts. Security is a critical aspect of any enterprise's operation and is of particular concern to any DevOps practitioner working within the enterprise. Overview and features of Jenkins. Jenkins as a continuous integration tool. Jenkins is a Java-based open-source automation tool. It functions as a server and is a software development and cross-platform tool used for continuous integration and continuous deployment. Let's look at what Jenkins can do. As a continuous integration server, it can be used as a CI server or a continuous delivery hub for a project. In terms of distribution, it can easily distribute work across different machines and help trigger builds, tests, and deployments to multiple machines and platforms quickly. Jenkins is designed to work cross-platform. It allows programming in software development environments such as iOS, .NET, Android, Ruby, and Java. Architecture of Jenkins. Jenkins is a comprehensive CI/CD framework that is designed to be flexible and extensible. It has a distinct object model that has classes like project and build. These classes describe the various components of the framework. It uses Jelly as the view technology. It uses the file system to store its data. Directories are created at the location on disk defined by the environmental variable Jenkins_home. It supports plugins which are plugged into those extension points and extend the capabilities of Jenkins. Popular features of Jenkins. Let's take a look at the features. 1. Jenkins is platform independent. 2. It has a rich plugin system. 3. It has the support of a large community of third-party developers and expert users. 4. It's designed to scale to meet the needs of the large enterprise. 5. Its automation capabilities enable immediate detection and resolution of issues. 6. It's open source and user-friendly. And 7. It's easy to configure, modify, and extend. Build status and job health. Every time a Jenkins job runs, the status of the build gets reported. The figure on the left side of the slide shows the results of a few runs of a build project. Notice that the result of each build is reported. Sometimes the build succeeds. Other times it fails. If an administrator aborts or disables the build, that gets reported too. The figure on the right side of the slide provides a description of the overall health of the project according to many builds. Assisted practice. Set up Jenkins. Let's take a look at the assisted practice. You are given a project to install and configure Jenkins on the Ubuntu operating system of your Learning Lab virtual machine. Lab 3.1. Installing and configuring Jenkins. In this demo, we're going to describe 3 steps to install and configure Jenkins. First, we're going to modify the file sources.list. Then we're going to use apt-get to install the Jenkins package. And then finally, we're going to run Jenkins in the browser. So let's get started. First, at the command line, we type make dir lab 3.1. Then, at the command line, we type cd lab 3.1 to navigate into the directory we've just created. Now, we need to add the key from the Jenkins package repository into our local environment. At the command line, we type wget -q -o https package.jenkins.io/debian-stable/jenkins.io-key pipe sudo apt-key add dash, and this will add the key directly into the apt-get file system. Now we need to update the file sources.list. We'll use the Vi editor that's already installed in your classroom virtual machine. At the command line, we type sudo space vi space /etc/apt/sources.list. Sources.list is the file that apt-get uses to locate package repositories on the internet. We strike the I key on the keyboard to put Vi into insert mode. We scroll down to an empty space in Vi and type deb https://pkg.jenkins.io/debian-stable space binary /. Then we hit the escape key to get out of insert mode and type :W for write, Q to quit Vi. Now we have to update the package manager. At the command line, we type sudo apt-get space update. Update executes. Once we see the line reading package lists ... done, the update is complete. Now we need to see if Java is installed, and if not, we need to install it. At the command line, we type java space -version. As you can see, Java and the Java Development Kit is already installed. If Java was not installed, you would type sudo space apt-get space install space openjdk-7-jre. This command will execute apt-get to install the OpenJDK package. Now we install Jenkins. Type sudo space apt-get space install space Jenkins. Strike the Y key to confirm installation. The installation process will take a few seconds. Now we're going to open the initial installation of Jenkins in a browser. We go back to the virtual machine desktop. In this case, we'll load the Firefox browser. We're going to enter the IP address of the Jenkins installation. The IP address was assigned to the virtual machine earlier. In the address bar of the Firefox browser, we enter the IP address 172.31.26.234:8080. 8080 is the port where the Jenkins server is running. Please be advised, the IP address of your virtual machine will be different, and the way you can discover the IP address is at the command line, type ifconfig. The IP address of your virtual machine will be in the information displayed. The first screen we're shown is the Unlock Jenkins screen. We're going to need to enter the administrator password in order to continue. As you can see in the red type, the location of the password is a file /var/lib/jenkins/secrets/initial-admin password, where initial admin password is the name of the file that contains the password. We return to the terminal. We type clear to clear the screen. At the command line, we type sudo space cat space /var/Jenkins/secrets/initial admin password. We strike the Enter key to display the password. We highlight the password in the terminal and then copy it by right-clicking on the mouse and selecting Copy. We return to the browser and paste the password into the administrator password text box. Then we click the Continue button. Firefox will offer to save the password, but we'll click Don't Save. We have the option to install suggested plugins, or we can select specific plugins to install. We're going to go with the Install Suggested Plugins method. We click the box labeled Install Suggested Plugins. The Getting Started page appears and the plugin installation continues. Once downloading and installing the plugins is complete, you'll be presented with the Create First Admin User page. At this point, we've successfully installed Jenkins. Now, the next steps will be to create the admin user by putting in a username, password, confirmation of password, a full name for the user, and the user's email address. Let's recap the important steps. Assisted practice, guidelines to install and configure Jenkins. Log into Ubuntu Lab provided with the course. Open the terminal and execute the command available in the lab document 3.1 to add the key to the system. Edit the sources.list file and add the command to the file and then save it. Update the apt-get package. Install JDK 8+ version. Install Jenkins using apt-get package. Navigate to the IP address of the machine denoted as x.x.x.x:8080 in the browser of your virtual machine. Get the password and enter it into the Jenkins window. Create a new role job in Jenkins. Explore the Freestyle project and build section. Overview and the features of TeamCity. TeamCity as a continuous integration tool. TeamCity is a Java-based management and continuous integration server. It's licensed commercial software that's used for continuous integration and continuous deployment. TeamCity supports a number of features that are important to the continuous integration process. For example, gated commits ensure only working code is committed to deployment branches in source control. TeamCity supports integration with various integrated development environments such as Eclipse and IntelliJ. It has a build grid that describes build activity. Also, it has cross-platform support for a variety of operating systems and programming languages. Also, TeamCity has seamless code integration. TeamCity Workflow. TeamCity supports the CI/CD process that has become the standard workflow for many companies and software development shops. Let's take a look at the overall workflow. As you can see in the slide at point 1, the first step is that a developer or tester checks code in to the source control management system. Upon commit at point 2, a build trigger message is sent to the TeamCity server. Then, at point 3, TeamCity works with system unit testing to start the system unit testing automation process. If the code passes the test, artifact building, archiving, and deployment tasks are performed in an automated manner at point 4. TeamCity reports the status of all the activities at point 5. Popular features of TeamCity. TeamCity has many features that make the CI/CD process more efficient. Let's take a look at the features. TeamCity has pre-tested commit, instant notifications, it has code coverage and monitoring capabilities, it provides a comprehensive build infrastructure, and it has enhanced version control system integration. TeamCity makes it easy to verify code, and it offers configurable test reports. And finally, TeamCity supports managing users and roles. Assisted practice. Set up TeamCity. Now it's time to do an assisted practice to set up TeamCity. You're going to be given a project to install and configure TeamCity on the Ubuntu operating system in your Learning Lab virtual machine. So let's get started with Lab 3.2, Install and Configure TeamCity. First, we create a directory for the work. We type mkdir lab 3.2. Then we navigate to that directory by typing cd space lab 3.2. First, we're going to download the compressed GZ file for TeamCity. Then we're going to extract the files from the compressed file. We're going to move the extracted directory that contains the files into another location. We're going to start up TeamCity. And then we're going to go to the browser and register a user with TeamCity. Let's download TeamCity. We go to the desktop of our classroom virtual machine, and then we click on the icon for Google Chrome. Chrome appears. In the Chrome address bar, we type www.jetbrains.com/TeamCity/download. We click the download button. The GZ file downloads and the thank you page appears. We return to the terminal. At the command line, we type cd /home/Ubuntu/capital downloads/. We strike the enter key. This takes us to the directory where the GZ file has been downloaded. At the command line, we type ls to confirm that the GZ file is indeed in the directory. Notice the file teamcity-2018.2.1.tar.gz is listed. Now we need to extract the files. At the command line, we type tar space zxvf space teamcity-2018.2.1.tar.gz, and we hit the enter key. This will extract all the files into a directory named TeamCity. Now we need to move the directory TeamCity into the directory /opt/JetBrains. We create a directory by typing sudo space mkdir space /opt/JetBrains. Now we need to move the directory TeamCity into the directory /opt/JetBrains. At the command line, we type sudo space mv space teamcity space /opt/JetBrains/TeamCity. We strike the enter key. Now we need to give full read, write, and execute permissions to the files in the newly created directory TeamCity. At the command line, we type cd space /opt/JetBrains. We strike the Enter key. Then we type chmod space -R 777 TeamCity /. This says to give all rights to the directory and the contents of the directory TeamCity. We type ls just to make sure the directory TeamCity is indeed there. We type cd space TeamCity / and hit the Enter key to enter the directory TeamCity. Then we type ls to take a look at the contents of the directory TeamCity. Notice there is a bin directory. We navigate into the bin directory by typing cd space bin and hit the Enter key. Let's clear the screen to make things easier to see. To invoke TeamCity, we will execute the bash file ./teamcity-server.sh space start. It's very important that you use the ./ characters. We hit the Enter key and TeamCity starts up, spawning TeamCity and then TeamCity restarter running with PID 11618. And the PID, the process identifier, will vary according to systems. Now TeamCity is running. We go back to the browser, but before we do, take notice of the IP address of the virtual machine, which is shown on the command line on the left-hand side. The IP address of this virtual machine is 172.31.26.234. In the address bar of the Chrome browser, we type 172.31.26.234:8111, which is the port on the IP address where TeamCity is running. The TeamCity First Start web page appears. We click the Proceed button. The TeamCity is starting page appears. Then we see the database connection setup page. TeamCity allows you to choose from a variety of databases. We can use Postgres, MySQL, Oracle, or MS SQL Server. We're going to use the internal database. TeamCity creates the database and initializes its server components. This phase of the setup can take a few minutes. The page will reload automatically once TeamCity is through installing its server components. We're almost done with TeamCity's installation process. Then all we'll need to do is to create an account in TeamCity. When the installation process is complete, we'll be presented with the licensing agreement that we have to agree to. We scroll to the end of the terms and conditions. We click the checkbox for Accept License Agreement. We're going to uncheck Send Anonymous Usage Statistics. Then we'll click the Continue button. the web page Create Administrator Account appears. We enter the username Simplilearn. Then we add a password and confirm the password. Finally, we click the button Create Account. We'll also save the username and password information in Google Chrome. Upon successfully entering a username and password, we'll be presented with the My Settings and Tools webpage in TeamCity. The page allows us to access projects and changes and agents, as well as build queues. In the next demo, we'll look at more details. Let's recap the important steps. Guidelines to install and configure TeamCity. Number 1, log in to your Ubuntu lab provided with the course. Number 2, download TeamCity from the official site. 3, unzip the folder and install TeamCity. 4, provide the read, write, and execute mode access to TeamCity. Number 5, run TeamCity at x.x.x.x:8111, where x.x.x.x is the IP address of your local machine, or the machine where the server is running. 6, create an account in TeamCity and add the basic details to complete the setup process. 7, explore options such as projects, changes, agents, and build queue. Build tools and their uses. Build tools. Build tools are programs that automate the creation of applications from source code. Automation tools allow the build process to be more consistent. Some common build tools are Make, Bash, which ships with Linux, Ant, Apache Maven for Java, Grunt, and Gulp. Popular features of build tools. Well, we can start with compiling to binary code for languages such as C# and Java. Build tools will package a compiled program for deployment. Also, it will run automated test cases against the code. The build tool will deploy artifacts to production and will also generate documents for developers to use for later reference. And finally, a build tool will generate release notes. An overview of Apache Ant. Apache Ant is a Java library and command line tool. Its aim is to provide processes described in build files as targets and extension points dependent on each other. Let's take a look at some of the distinct features. Apache Ant supplies a number of built-in tasks that allow it to compile, test, and run code. It's flexible and does not impose coding conventions. It builds solutions by combining build tools and dependencies with Apache Ivy. It solves Make's portability problem. And users can develop custom Ant libs using Java. And finally, you can use Ant to pilot any type of process. The limitations of Apache Ant. In Apache Ant, there are a few limitations. Some of the limitations are, number 1, configuration error checking is limited. Undefined properties are not raised as errors, but are left as unexpanded references. Number 2, Ant has limited fault handling rules. Lazy property evaluation is not supported. Thus, you need to be very exact when configuring Ant. It is not a forgiving environment. Number 3, older tasks use default values, which are not consistent and can cause problems. You need to pay attention. Changing defaults can break existing Ant scripts. And finally, number 4, Ant build files are complex and verbose, as they are hierarchical and partly ordered. An overview of Maven. Apache Maven is a comprehensive software project management tool. Based on the project object model, also known as the POM, Maven can manage a project's build, reporting, and documentation from a central XML file. Let's take a look at the key points of Maven. Number 1 is backward compatibility and auto-parent versioning. The hierarchical structure of the POM XML file reduces the burden on version control and reconciliation of dependencies. Number 2, Maven supports model-based builds. Number 3, Maven supports parallel builds and better error integrity reporting. You can kick off a number of project builds that run asynchronously. Number 4, release management and distribution publication is built into Maven. The project object model is comprehensive and covers all aspects of the software development lifecycle, from development through testing and on to release. Number 5, instant access to the latest features with less or no additional configuration. Maven allows artifact version control that can be set to get the latest release of a dependency. Thus, you can make sure the code is always up to date. 6, large and growing repositories. There is a complete ecosystem of Maven artifact repositories that make it so you have access to popular components automatically. The Maven repository, found at https://mavenrepository.com, is a popular one. Also, a company can set up its own private repository. The drawbacks of Maven. Maven does have some drawbacks. Number 1, unable to depend on outcome status. Maven builds can fail, leaving nothing behind other than error messages that can be very hard to understand. Number 2, Maven is verbose and complex. It does take a while to master the details of the platform. Number 3, slow and partial black box. Maven does a lot of things automatically, and sometimes these black box activities can be very opaque. And finally, number 4, Maven can be unreliable when integrated for use within the Eclipse IDE. Comparing Maven over Ant. Well, Maven has better dependency management. It provides more powerful builds. There's better collaboration, and the debugging capabilities are a bit better than Ant. There's more componentization in the builds, and there's reduced duplication. And finally, the POM provides a more consistent project structure. The project object model, also known as the POM. The project object model is an XML representation of a Maven project. It provides general configuration information, such as a project's name, its owner, and its dependencies on other projects. The XML excerpt in the slide shows a rudimentary implementation of Maven's project object model. The POM XML needs to define the group ID, the artifact ID, and version. The packaging needs to be declared too. The default deployment package is a jar. The project described in the XML file in the slide has an artifact ID of calculator. You can think of the artifact ID as the name of the artifact that's going to be created. The POM shows a version of 1.0 and it belongs to the group with the identifier EU.TotalEclipse. You can think of the group ID as a way a company organizes a number of artifacts under a common name. Overview of Grunt. Grunt is a JavaScript-based task runner which is used to automate repetitive tasks in a workflow. It can be used as a command line tool for JavaScript objects. Let's take a look at some of the key points to understand about Grunt. In Grunt, developers write Grunt setup files to ease workflow. Thus, Grunt speeds up the development flow and enhances performance. It helps with the automation of repetitive tasks with less effort. It supports a small infrastructure, which is a best fit for new code bases. Grunt minifies files such as HTML and CSS, thus reducing the potential problems with network latency. Grunt aims at reducing the chances of errors during repetitive tasks, And it includes built-in tasks to extend functionality of plugins. Currently, Grunt has over 4,000 plugins and can be used in large production sites. An overview of Gulp. Gulp is an open-source JavaScript toolkit used as a build system in front-end web development. It automates time-consuming and repetitive tasks involved in development. Some of the key features of Grunt are code minification and concatenation, usage of pure JavaScript code. Grunt converts files created under less or SAS in a CSS compilation process. Less, which stands for Linear Style Sheets, is a dynamic preprocessor style sheet language that can be compiled into cascading style sheets, also known as CSS. And these style sheets are run on the client side or the server side. SAS is a preprocessor scripting language that is interpreted or compiled into cascading style sheets. Grunt also manages file manipulation in memory. Some of the advantages of Grunt are that it's easy to code, it's easy to test with web apps, and the plugins are simple to use. Some of the disadvantages of Grunt are there's more than the usual number of dependencies, multiple tasks cannot be performed in parallel, and configuration can become tedious. Assisted practice, continuous integration with Jenkins and Maven. You are given a project to configure in Jenkins. You need to make Jenkins poll get commits and build the project code using Maven on the Ubuntu operating system on your practice lab VM. Okay, so let's get started with Lab 3.3, continuous integration with Jenkins, Git, and Maven. In this lab, we're going to configure Jenkins to support Git and Maven. Then we're going to configure a Maven project. And then finally, we're going to build the Maven project using source code from Git. So in a web browser, we open Jenkins, and what we do in our classroom virtual machine is we go to the IP address, and in this case it's 172.31.26.234:8080, and Jenkins typically runs by default installation. We click the New Item link, which is on the upper left of the Jenkins web page. The New Item web page appears. In the New Project text box, we enter the project name, in this case, Java Maven. Then we select Freestyle Project, then scroll down the web page and click the OK button on the left-hand side. The web page for the newly created project loads. We add text to the description text box. This is a simple project to test Jenkins. We go to the menu bar at the top of the project's web page and we click the Build tab. We're taken to the Build section of the web page. We click the Add Build Step button to display a drop-down of options. From that drop-down list, we select the item Execute Shell. In the command text box, we enter the Linux command echo space quotation mark hello space from space Jenkins quotation. We click the Save button on the lower left. Now we'll do a test build to make sure everything's working all right. On the left-hand side of the project web page, we click the link Build Now. The build starts, and when it completes, you'll see a blue circular icon in the Build History section of the project web page on the left side. And you can see there's a build there, and it's labeled number 1. To the right of build number 1 is a drop-down arrow, which we click to get a list of options, and we select Console Output. Selecting Console Output will display in the web page the build log activity. Notice there's a line that says Hello Jenkins. This is from the echo command we entered in the Jenkins build configuration. Let's develop the project a little more. What we need to do is to add Git integration and get the project to work with Maven. We go to the Simplilearn site on GitHub, and that's Simplilearn DevOps Official. And we go to the repository Java Maven App. On the GitHub site, we click the green Clone or Download button to display the URL that we can use to access the Java Maven app repository on GitHub. So we highlight the URL and copy it. We go back to the Jenkins web page. In the Jenkins web page, on the menu bar, we click the tab for the Java Maven project. The Java Maven project appears. On the left side of the project's web page, we click the Configure hyperlink. This loads the project's configuration page, in which we click the Source Code Management tab. We're navigated to the Source Code Management section of the configuration page. There, we click the option Git. We paste the URL of our Simplilearn Java Maven app repository into the text box Repository URL. Entering a valid URL will make the error message, "Please enter Get repository," disappear. We're going to select some predefined credentials from the credentials dropdown. We added those earlier, but if you need to add credentials in the future, simply click the Add button and then select Jenkins. Now, if you're using your own GitHub repository, you'll be presented with the Jenkins Credentials Provider dialog. You're going to need to enter your username and also your password. Once we configure access to the Git repository, we click the Save button. Now, what we've done is we've effectively given Jenkins the right to access our GitHub account using our credentials. In other words, Jenkins is impersonating us. After we save the Git configuration, we'll be brought back to the projects page. We need to go back to Jenkins Home. We click the Jenkins tab on the upper left of the project page. This takes us back to the main Jenkins dashboard page, which we can think of as home. Now, we click Manage Jenkins on the left side of the Jenkins home page. On the Manage Jenkins page, we select Global Tool Configuration. The Global Tool Configuration page appears. We scroll down to the Maven section of the Global Tool Configuration page. We click on the button Add Maven to add a Maven configuration. We're going to give this installation a name, and we're going to call it Local Maven. Then Maven needs to know where its home is on the classroom virtual machine. In the text box labeled Maven_home, we enter the value /usr/share/Maven. An alternative method is to again click on Add Maven, add a name, this time Maven, and then from the Install from Apache dropdown, select the version of Maven that's on the machine. We've now let Jenkins know about Maven, so we can click the Save button. We return to the Manage Jenkins page. We need to return to the project. In the upper left-hand corner of the Manage Jenkins page, we click the Jenkins button. We're brought back to the Jenkins main dashboard. You can see Java Maven in the list of projects on the main dashboard. When we hover over Java Maven, we'll see a down arrow. We click that down arrow and some options appear. We select Configure from the Options dropdown. the Java Maven project's configuration page appears. We click the Build tab in the menu bar. You can see the echo command that we created previously in the Build section. We want to get rid of it. So what we're going to do is we're going to go to the right side of the Execute Shell section and click the red button with the X label. Clicking the red button deletes the Execute Shell command, echo, from the Build section. Now we want to add a new build step. We click the Add Build Step button and we notice that another drop-down appears. From that drop-down we select Invoke Top-Level Maven Targets. After we add the Maven build task, we'll be presented with a Maven version drop-down. This will contain the Maven configurations we created previously. We select one of the configurations. In this case, we'll select Maven. Let's recap the important steps. Assisted practice, guidelines to configure Jenkins and Maven. Number 1, log in to Ubuntu Lab provided with the course. Number 2, log into Jenkins and create the first Jenkins job. Number 3, install and configure Maven. Number 4, configure Jenkins with Java, Get, and Maven. Number 5, create a Jenkins job for your Maven build project and run the project. Number 6, poll Git for commits and automatically trigger the build. Number 7, build a trigger using the push mechanism instead of pull. Number 8, repeat steps 6 and 7 multiple times to observe the results in the console output section.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.